Hi, and welcome to day 12 of Python Challenge. And today we're going to talk about networked programs. So without further ado, let's get started. So at the beginning, these slides are from Professor Severance. Is about his book about the introduction to networking. If you have more, if you want to get more information about networking for programmers, you can refer to this and many other books that you can find in the internet. Basically, what we're going to talk about today is about the OSI model, and which is basically a way for computer programs to talk to each other. So at the very top, we have the application layer. After that, we have transport layer. Then we have internet and link layer. So basically, we're not going to talk about internet and link layer in this topic, in this session. That's a different session, basically, a different class. What we're gonna, and these two layers, what they're gonna do is that they will make a reliable connection between the source and the destination that we want to have communication between. What is important here is about the transport layer. In the transport layer, what we're going to do basically is we're going to create a connection between the source and destination, or client or server or peer-to-peer. And we're just going to assume that the underlying layers are going to make a reliable connection for this connection to happen at this is kind of as a higher level connection. And that's what we call a socket, basically. This connection is called a socket. And the communication is happening using the TCP, which is a Transport Control Protocol. And basically it handles the flow control and the handshake that happens between the client and server or peer-to-peer communication. And at the end of the day, it will provide a reliable pipe between these two transport layer, which eventually will be used by the application layer on top of transport layer, so the two applications can talk to each other. A good analogy, of course, would be comparing that connection with making a phone call, and basically that's a very good analogy that we can use for that. As mentioned, we're going to talk about sockets. So basically, socket is bidirectional communication flow between the two endpoints. They can be, again, peer-to-peer network, or it can be a client-to-server network. And that's what we call a socket, a bidirectional communication, bidirectional inter-process communication between two clients. Another concept that we have to know about is the concept of the port number. So the port number, a good analogy again would be if you call a company, making that connection and making that phone call is similar to have a socket, but knowing the extension that you want to reach at that organization would be synonymous to the port number. So basically, port number is the extension that you want to dial. And in computer world is basically with the socket, we make connection to the server or to the other client. And with the port number, we specify the application that we want to access through those connection that we made using sockets. So that's a good analogy to keep in mind. So basically, a port is an application-specific or process-specific software communication endpoint. So there are some well-known ports that we use on a daily basis. Even probably we don't know about them, but for example, the incoming email or simple mail transfer protocol (SMTP) is using port number 25. Login and secure login, we're using 22 and 23. For web services, we usually use 80 or 443 if it's a HTTPS. And for personal mailbox, we're using 109 or 110. And those are softwares that we use, for example, when we want to read the email on our laptop. For example, Outlook is an example in Windows, or Thunderbird in Mac OS. So again, some common port numbers. 23 is Telnet, 22 is secure shell, which is secure login. HTTP, which is we are going to mainly talk about today, is on port 80. HTTPS 443, SMTP 25, IMAP, POP, DNS, and FTP have all common, well-known TCP ports. So basically, again, talking about the and sometimes talking about the ports, sometimes we see that the port number in the actual URL address. So sometimes it's, and that happens usually if we are using a different port than the well-known port that is specified for those purposes. For example, in this case, HTTP is usually using port 80, but in this case, we are using port 8080 to have a HTML or HTTP, let's say, connection. So sometimes we can see the port in the actual browser. And that's happened if that port is non-standard. So we're going to talk about how to create a socket in Python. It's pretty easy. We're going to import the socket library. Here we prepare the socket. So basically we assign an object which is called mySocket, and we define some parameter here. We define that this socket is gonna work as a stream, which is in contrast with working. So all the character will be streaming, in contrast to what the other option, which is block, which all the characters are going to move through in a block. And basically we initiate that socket using this command, and now we're going to associate that socket to start the connection to this URL, to this address, using this specific port. So by using the connect, we're going to associate this socket connection to the destination that we would like to have, and specifying the port that we want to basically dial into, the extension, if you will, that we want to use in that aspect. So this slide talks about the simplicity of how making a socket is compared to other programming languages. And of course, if you want to do the same thing in the other programming languages, it would have taken us much time and more resources to write that, basically. Now we're going to talk about application protocols. So we talked about the transfer protocol, that basically TCP was the one that we're going to be mainly using, and we use that transfer protocol, the TCP, to make that connection, make that call. And So basically, that TCP is giving us that reliable socket. And now what we're going to do with that reliable connection. So some of the protocols that we know, of course, are Mail Protocol and World Wide Web. Another protocol that we gonna work with is HTTP, or Hypertext Transfer Protocol. So is basically the dominant application layer protocol in the internet, and it was invented for the web, and it was invented in order to retrieve HTML, images, documents, and all other sorts of information. And it can also be extended to be used in data in addition to the documents, which are in form of RSS, web services, and other information. And the basic idea is to make a connection, request the document, retrieve the retrieve the document, and close that connection. So that's why we use HTTP, or Hypertext Transfer Protocol. So again, HTTP is a set of rules to allow browsers to retrieve web documents from servers over the internet. And the protocol, what it means is basically a set of rules that we use in the computer world in order to communicate with each other, how to initiate the connection, how to terminate, how to send information over internet. And basically there are sets of rules that both ends agree upon at the beginning, so the communication can be handled properly. A good analogy again would be choosing which side of the road cars should drive. It works well it doesn't matter which side you choose. It works well as long as everybody else follows that rule. But of course, if the cars start picking up randomly a different side each time, it's going to be a chaos. So we need the protocol in order to make sure that all the communications happens in a certain way that both parties that are involved agree upon. So there is a YouTube video about Robert Kallio, who is one of the inventor of HTTP. He was working on CERN, and one of the big idea that they came with at that time was, I believe it was in 90s. One of the big ideas that it is kind of is taken as granted right now is basically when we have a URL, we start with the protocol, then we get to the host address, and then we get to the document name that reside in that host address. So again, that was one of the main ideas that was introduced by one of the inventor of web, Robert Kallio. So till now we were able to know that, okay, with the socket we make a connection. How are we gonna get the information from the server? So each time we click on the link on the web page, basically we are using a href, which is a HTML tag to use a different link to send us to redirect us to a different link, basically. So what we're going to do is we're going to send a GET request whenever we click on the link, and that GET request will go and retrieve the content of that link that we clicked on, and it will bring it back to us. And basically the server returns the HTML document in the browser, and the browser, what it does is basically formats and display that document to the person who clicked that information. Okay, so here it is. This is the sample page of Dr. Chalk. So we click on this link, which is the second page. What it does, the browser will go to the web. We issue a GET request for this page 2, which is the content of this second page, which is defined by the HTML language. So we send a GET request. The browser will go to the wherever that address is pointing to, and we get a response. The response would be in the HTML format with basically, in this case, it's going to be some text wrapped into different HTML tags. And after that, the browser will transfer that or encode that data to what here looks like to be, or it is to be, the second page. This was the first page and this was the second page, and this is the content of the information that we got back from the server. So that's basically the job of the browser. When we clicked, it got the information, it parsed and it encoded it in a way that we were able to see these HTML codes that in the first look might not look familiar, that it is supposed to look like this. Okay, so the internet standards and protocol are developed by an organization which is called IETF, Internet Engineering Task Force, and those standards are called RFC, or request for comments. And the idea is that with every protocol, there is always a RFC, basically, which is a big document to improve that protocol or improve that idea, if you will. So basically, that's how internet protocols are improving and getting better every day because of these RFCs, because people come from different universities and different organizations and contribute more features by writing these RFCs. So if you go to W3 and look for the protocol and look for RFC 2616, that's basically the HTTP version 1, which was, I don't know the year, but 1999 actually. And yeah, basically that's the first version of the HTTP that was written, and that was the RFC that was related to this version. And everybody can read it and get information from it. And here we can see that, for example, we have a request, and the request is from a client to a server, which includes the first line of the message, method that would be applied to get the resources, identifier to the resources, and protocol version of it, which is all displayed here. So this is basically information about HTTP in the RFC. Okay, now we're gonna do a HTTP request. So as we mentioned, we have to use a GET. So what we're gonna do, we're gonna connect to a sample server. I tried this recently. I think this server is not responding anymore, but the idea is we get connected to this server using HTTP and send a couple of GET command to make a HTTP request. Okay, the way that we can do it, this is the command line from an Apple OS, a Mac OS. If you have Windows, I think you can install the telnet program. And what you're doing here is basically we are doing a telnet to this address using this port. We get the connection here, and we get connected. After that, we post or we paste, let's say, this command, which is gonna get this address, and using this HTML format, we have to enter twice. And what we get here is basically first we get the header of this page, which is basically some information about the page. And after that, we get the content of it, which is, as we mentioned before, is in HTML format and with all these tags that are related to the HTML format. So by using the telnet command, we were able to connect there to the port 80, and we were able to paste this command, which would end up getting this link back for us, which has the header of it here and the content of it. So if you go to some movies actually, and the concept of the hacking, basically the idea is the hacker who always work with the command line. The reason is you always have this fancy graphical user interface in the front, but all the action happens in the back, and a good hacker knows how to work in the command line, and of course he or she has to know how the program works, sometimes better than the person who wrote it, in order to achieve what he or she wants, basically. Okay, and this was actually Matrix Reloaded, one of my favorite movies. Anyway, so let's talk about how we can write a web browser. So what we're gonna do, we're gonna import the socket. So socket is basically what makes a reliable connection with the TCP protocol. So what we're gonna do, we're gonna prepare a socket. We're gonna say that, okay, this is gonna be a streaming one. We're gonna initiate it, and we're gonna say that, okay, create an object for us, which is called mySock. We use the connect function to connect to port 80 of this address. And what we do here is we use the get command. So now till to this point, we basically made that phone call. So we know that we are connected. That connection is there. Now what we're gonna do is use the get command to get the content of this URL. We're gonna put 2 times enter, if you will. We're gonna encode it, which we're gonna talk next about this, and basically, and we're gonna put all of that in the command object. We're gonna send that command using the socket, and by doing that, we start retrieving information from that server. We have a while loop here, which is going to run, and every time it gets 512 character of that get request or HTTP content, and put it in the data. If the length of data is less than 1, which means that if we don't happen to receive anything more, which means that we got to the end of our HTML, we're going to break, we're going to come here, we're going to close the socket. Otherwise, we're just going to um, print it, and we're just gonna decode it, and we're just gonna print it. And we're gonna get to the decode and encode in a little bit. So basically, if we run that program, this is what we get. This is gonna be the header of this, and this is gonna be after that the content of it. So basically, that's the HTTP header, and this is the HTTP body. So let's talk a little bit about characters and string. At the time when the computer started to develop, it was the only language, of course, was English, and the character that they were using was basically the character set that they were using was ASCII, which is American Standard Code for Information Interchange. ASCII has only English on it. Basically, it doesn't include Spanish or Latin or German or other European language. It absolutely doesn't have any African language or Middle Eastern language or Eastern language or Chinese or any other language. It's only English. The way that is so it's basically simple string simple alphabet, simple English alphabet. So one of the way that we can find out about the orders, because the thing about ASCII is 8 bits, so it's a byte, and it's 256 character, and here, 8 bits of memory. So with 8 bits, 0 to 256, and the way that we have it here is basically from 0 to 127. And each character has an order. So we can get the order of that character if we use the ord function. So here we have, for example, ord H, and H, capital H comes before, capital letters come before smaller letters. So here in comparison with capital H and small e, capital H has a lower order, which here we can see 72 is capital H, which is less than small e. If we look at the \n, and we use backslash to say that consider this as a character, consider \n as a character, which is a new line. A new line is going to be number 10, which is here. And I forgot what LF stands for, but that's definitely a new character, a new line. So that's how we can find the order of those characters, ASCII characters, in the ASCII table. Again, in 60s and 70s, there were not many other languages. They were just happy just to print English, of course. As time grew and grew, more countries contributed to the IT development, and of course more languages were needed to be able to communicate between different countries. So we have all kind of different languages, all kind of different character sets, and the ASCII absolutely was not sufficient at that time. So what happened was UTF, which is a multi-byte character. So the UTF standard, we have UTF-32, which is a 4-byte, and it can include all the possible language and character set that exist at the moment. there is a shorter version of it that has a subset of that, which is UTF-16, that has only 2 bytes. But the most common one that is used right now is UTF-8. So UTF-8 is like a compressed version of UTF-32, and what it does, the size of it is changing between 1 to 4 bytes, and depending on the content that we are transferring, the size is gonna change. If it's 1 byte size, it can cover all the ASCII characters as well. So this is a chart that shows that as time progresses, the UTF has been used more and more in internet. Okay, so there is a difference between the Python 2.7 and Python 3.5. The difference is that in Python 3, all strings are Unicode, which has in Python 2, some strings were not Unicode. Some strings had to be, in this case, you had to combine an ASCII with a non-ASCII to get a Unicode. And if it was non-ASCII, it would have been string. But here, if it's non-ASCII is a string. If it's ASCII and non-ASCII is also a string. So in Python 3, all the strings are Unicode. That's the difference. Okay. Because of that, so the other thing is that, for example, here in Python 2, if we have a B column, ABC column, that type would be string. But in Python 3, B column, ABC column, the type of that would be byte. So basically, and it's byte because it's Unicode, whereas here is a string because it is a string. So that's the difference between Python 2 and Python 3. Again, in Python 3, all the strings internally are considered as Unicode. Working with strings, variables in Python programs, and reading data from files usually is just fine. When we talk to a network resource using socket or talk to database, we have to encode and decode data, usually in UTF-8. So that's important, that we have to encode and decode data when we want to read or write data from or to network. Okay, so if you remember, we had this idea that when and the previous code that we were writing, we were receiving all those information, and in this while block, we had to decode it because those data that were given to us by the get command were already was encoded to UTF-8, and now at the destination, we are encoding them and putting them in a basically unpacking them from UTF-8 and putting them to the ASCII or Spanish or whatever language they would represent that at the time of the encoding. Okay, again to that idea, so you see in the get command that we had to encode it. So whatever it was, if it was Japanese, it was Arabic, it was English, French, whatever, we would encode it to a UTF-8, and at the destination we had to decode it back to whatever language we took it from. so we can read it. So some documentation about encode and decode. So basically, decode, let's start with encode. Return an encoded version of the string as a byte object. Default encoding is UTF-8. And decode is return a string decoded from a given byte. Default encoding is again UTF-8. Yes. Okay, so basically the same idea. When we send a request, we send it like this. I'm just thinking which one is the source, which one is the destination. Here we are sending this one, we are receiving this one. Okay, so yeah, so we send this request, we encode it to, we send a request, we send we send the get command, and we encode it. When we put our get command, we encode whatever it is here and send it to the requester, and then the requester, we use the decode to represent whatever original language they were using. If we are sending something here, we're gonna again encode it to the UTF-8, and at the receiver we're gonna decode it basically for them to be able to read whatever we encoded. Okay, now we're gonna make another HTTP or web browser using URLlib, which is another library, which makes it a bit easier. So in this case, what we're gonna do, we're gonna import the URLlib and a couple of other libraries, URLlib parse and URLlib error. We create a file handler, which is and we put the address of the destination website that we want to retrieve data from. And after that, we will we're going to open it. We're going to request it. We're going to take it. We're going to open it, and we put everything in the file handler. And we can have a for loop, which is going to go for each line in that file handler. And what we're going to do for each line, we're going to decode it, strip it, take the return carriage away, and we're going to print it. So that's exactly what we did in the previous example, just much shorter and compact. Oops. Okay. The other thing about the URLlib is we have to remember that the URLlib keeps the header and keep it. We can retrieve it. Of course, we don't see it here, but we can retrieve the header. But what we get here is only the content of the HTML that is enclosed in the HTML tags. So this is going to be the content. We don't see the header. We can't get it, of course. Okay, so again, one of the things that we have to do here is when we receive that information, we have to decode it, because you see here also the URLlib encode the information before sending it, so we have to remember to decode it. Going back to the original exercise that we always have which is counting how many pages are in counting how many words are in a page. We're gonna use the URLlib, put it in the file handler. we're going to create a dictionary. For each line in the dictionary, we're going to extract the words in that line, and for each line we're going to have a counter and add one word or one count per instance of word that we see, and at the end we're going to print that dictionary. Again, so this is going to be how we use the URL lib. When we decode it, again, we will take it back from UTF-8 to the original language that it was there. Okay, so the idea that Dr. Severin mentioned here is Python is a pretty popular language in Google, and the question is, could these 4 lines were the first line that they were written in the Google to parse different pages? So who knows? All right, now we're going to talk about parsing the HTML or web scraping. So what is web scraping? It's basically going to different pages and go to the link that are mentioned in those pages and repeat this process many times. And if you have enough time and resources, we can go through all the pages that has been referenced in the entire web. Why do we want to do it? Maybe we want to create our own search engine. Maybe we want to look for a certain information. Maybe we want to know how to create a web scraping machine. Who knows? So the idea here is we're going to pull the data. If there is some social data, who links to who, maybe we get back some system that has no export capability. We can maybe monitor some sites for new information. We can spider the web to make a database for a search engine. There is also some controversy about it. Some copyrighted materials, of course, we have to be careful. Maybe some website don't like a robot start scanning them. There is some terms and conditions that might be considered if they are not be violated. And basically, some website, if they detect that a computer or a robot is doing that, they might block the account or block the IP as well. Okay, so one of the libraries that exist is called Beautiful Soup. What it does is it goes through all HTML pages, and it can look for broken HTML references. The problem is there is a lot of broken HTML pages in the internet, and nobody basically cares to fix them. So a group of people or one person tried to find a way to create a package, and what it does is just go through all the pages, and it can give us all the references or all the HTML tags that was supposed to be there but has been forgotten. So you can download the beautiful soup from these locations, or you can install it or add as an extension to your Python installation. This is how you do it. No, I'm sorry, this is not how you install it. So basically what we need to do after we installing it, we're going to import it. This is the installation that Dr. Severance have. So from that, we're going to import beautiful soup. We're going to create a URL object, which is going to take whatever we enter, the URL that we enter. We're going to add the HTML object, which is going to read that URL that we entered, and we're going to put it in HTML. We're going to make the beautiful soup to parse that HTML object and put it in the object which is called soup. And here on the soup object, we can look for the tags which are starting with A. And we're gonna say that, okay, those are the href tags. So we're gonna print those tags. And here in the first page, we give that, when we run this program, it's gonna ask for the URL. We put the URL, and in this URL, we have only one href tag, which is on page, which is pointing to page 2. So that's going to be the output of that beautiful soup object. Okay, in this chapter we talked about a lot of different things. We talked about the TCP/IP and how to make socket connection between different computers and applications. We talked about application protocols to make use of these pipes or these connections that we made. We talked about HTTP, Hypertext Transfer Protocol, which is a simple but powerful protocol. And we talked about how Python can be used to create socket, HTTP, retrieve data, and HTML parsing. As always, all the copyright is for Mr. Charles Severance. And thank you so much for watching this. I hope this has been informative for you.